Hey class, welcome to Unit 2. We're going to start off Lesson 1 learning about matrices and matrix operations. First, a matrix is a rectangular arrangement of numbers that is in rows and columns. The dimensions are m by n, written like this. We say the entries or the elements is each individual number of the matrix. And we say that matrices are equal if they have the same dimensions and the corresponding elements are identical. So they have the same numbers in the same places. So for example, A here are equal matrices, because 2.5 is in the first row, first column, and that is equal to 5/2 in the first row, first column. Negative 0.2 or negative 2/10 is the same thing as negative 1/5, same row, same column. First row, second column is both -1, and then second row, second column both have a 3. And so this matrices are equal. Here you can see the first row, first column is not the same, so these ones are not equal in B. So each entry in each individual spot has to be the same. We say these are the rows, so like this one is like row 1, row 2, and then column 1, column 2, etc. It can continue going on like that. But we talk about rows go to the left and to the right, and columns are up and down. So if I asked for row 1, column 1 spot, that would be right here, row 1, column 1. In order to add matrices, they must have the same dimensions. So to add or subtract, they must have the same dimensions. So we measure, or we say the dimensions by rows by columns. So in A, this has 3 rows right here, row 1, row 2, row 3, and then 1 column. So it is a 3 by 1. And the next matrix is also a 3 by 1. So since they have the same dimensions, you can add the corresponding spots. And when adding or subtracting, your final answer will be a 3 by 1 as well. So 0 plus 1 is 1, 4 plus -9 is -5, 3 plus 8 is 11. Okay, here we have 1 row, 2 rows, column 1, column 2. So we have a 2 by 2 matrix and a 2 by 2 matrix. So we can subtract. You subtract row 1, column 1. So our answer will also be 2 by 2. 3 minus 2 is 1. 3 minus 0 is 3, and that's row 1, column 2 goes in row 1, column 2 spot for the answer. Row 2, column 1, 9 minus -3. When you subtract a negative, that's actually adding, so it's 12. And then row 2, column 2, -5 minus 5 would give me -10. In C, I have this matrix has 1 row and 2 columns, so it is a 1 by 2. And this one has 2 rows and 2 columns, so it's a 2 by 2. And so you cannot add those two because they do not have the same dimension, so that's not possible. Scalar multiplication is like a number outside of the matrix, like 6 times this matrix here in A. And scalar multiplication kind of follows the distributive property. Basically, if you have a number being multiplied by a matrix, you need to distribute that 6 to every spot. So 6 times 2 is 12, 6 times -3 is -18, 6 times 8 is 48, 6 times 4, 24. In B, matrix operations do follow the order of operations as well. So before you add these, you should multiply. So multiplication comes before addition. So scalar multiplication, distribute that -1 inside to everything. So just essentially changes the signs of each of those. Now this is a 3 row by 2 column, so it's a 3 by 2. And this is also a 3 by 2. You can see that they're the same size. And so you can add these two matrices together. Just make sure you add corresponding spots. So like row 1, column 1 goes together, row 1, column 2 goes together, and so forth. So adding those, -4 plus 1, or plus 3, -1, 7 plus 6 is 13, -3 plus 9 is 6, -3 plus -8 is -11. Really testing my mental math skills here. -2 plus 1 is -1, and 9 plus -4 is 5. So there we are. So matrices are used for multiple different reasons. We'll maybe talk about some more specific examples in class. But if you want to solve a matrix equation like this, what we're going to want to do is work on the inside here first and follow order of operations and combine the parentheses. So I'm going to add these two together and make one 2 by 2 matrix. So like 8 plus 4 would be 12. 0 plus -2x is just -2x. Then -1 plus 1 is 0. And 2y plus 6, they are not like terms, so it's just going to have to stay 2y plus 6 in that spot. Equals, and then this is 48, -48, 0, and 8. Now I'm going to distribute the 4 inside here, so 12 times 4 is 48. We got -2x times 4 is -8x. 4 times 0 is 0. 4 times 2y plus 6. Again, you have another distributive property there. So that's going to be 8y plus 24. And then equals 48, -48, 0, and 8. So the property of equal matrices say, if I say that these two are equal, then that means that the corresponding entries or elements in the corresponding spots must also be equal, which means that -8x has to equal -48. So if you take -8x equals -48, you can divide by -8 to finish solving for x, which would be 6. And similarly, that means that 8y plus 24, second row, second column, has to equal the same spot, second row, second column, 8 over here. So that means that 8y plus 24 needs to equal 8. So I can solve that, subtract 24 from both sides. To be 8y equals -16, divide by 8, and y equals -2. Okay, last one. The matrices show the number of hardcover volumes sold and the average price per volume in dollars for different subject areas. Calculate B minus A. How many more or fewer law volumes were sold in 1996 than in 1995? How many more or less did the average music book cost in 1996 than in 1995? So I am only going to subtract these for the specific questions instead of doing all of them. You could take this matrix B and subtract it from matrix A, but I'm going to look at just the specific questions. How many more or fewer law volumes were sold in 1996 than in 1995? So let's find law volumes. Law volumes here and law volumes here. So if I want that first question, I just want to know the difference between 827,000 and 716,000. So law volumes. So the difference was, it looks like they went up in 1996. So we sold that many more law volumes in 1996. So that was part A of the question. Okay, so how many more or less did the average music book cost? So the music is row 3, the cost is column 2. So row 3, column 2. So 43.27 minus 39.21. $4.06. Again, the cost actually went down. So $4.06 less in 1996. So that was answering the two using the matrices. All right. I think that'll be pretty straightforward for you. If you have any questions, let me know. Complete the student problems and get it turned back into me. Let me know if you have questions.